Today's lesson deals with the one operation that we have not yet done with polynomial functions, that is division. We've added and subtracted polynomials together, we've multiplied polynomials together, but we have yet to do division of polynomials. We're going to learn two methods. In this lesson we're going to learn the first of the two. It's called long division of polynomials. Now long division should be familiar to you, based off of long division all the way back in elementary school, long division of two numbers. To illustrate that, let's take a look at maybe 570 divided by 4. Okay. How would we set this up in long division? Well, we'd take the first term of 570, division sign goes around it, and then the second number 4 goes out in front. That's what we are dividing by. Okay. Now we're going to set up division of polynomials the same exact way. Okay. The first piece, we have 10x to the third plus 20x squared minus 35x minus 17 divided by x plus 3. This first part is called the dividend, and that is what goes underneath the division sign. So 10x to the third plus 20x squared minus 35x minus 17 goes under. The second part, just like the 4 over here, is the divisor. And that's the piece that goes out front. So x plus 3. So this is how we would set it up. We've got our dividend and we have our divisor. The dividend goes underneath, the divisor goes out front. The divisor is always the second piece because that's what you are dividing by. Now what we want to do is, now that we've set it up, we've defined terminology. We have seen that we set it up the same exact way that we set up long division problems years ago in elementary school. What was the process that we worked through to actually solve this problem over here, 570 divided by 4? Well, we started by saying 4 divided out of the first number 5. Okay, how many times does 4 go into 5? It goes in once. We then multiply that number down through. 1 times 4 is 4, and we subtract. 5 minus 4 is 1. You then drop down the next number of 7. Well, start the process and cycle over again. 4 goes into 17 4 times. Multiply down. 4 times 4 is 16. Do the subtraction. There's 1 left over. And then I can drop down my last number, the 0. Start the cycle again. 4 goes into 10 2 times. 2 times 4 is 8. Do my subtraction, and I have a 2 left over. So 570 divided by 4 is 142 with 2 left over. That's our remainder. We're going to talk about how to write that in a moment. But let's see if we can copy that same pattern, but copy it with polynomials instead. So we've already seen how to set this up. We set this up as 10x to the fourth plus 74x to the third minus 118x squared minus 48x plus 54 divided by our divisor of 10x minus 6. Okay, so working through this process the same exact way that we did the long division of the other polynomial looks like this. If I take my 10x here and divide it out of 10x to the fourth here, what do I have left? Well, 10 out of 10, that goes away. X out of x to the fourth leaves me with x to the third. It's kind of like factoring. You're factoring the 10x out of the 10x to the fourth. Now notice when we get the number up top, we don't worry about this negative 6 in our divisor. Okay? We only worry about the first piece. But now when we take this x to the third and multiply it down through, we multiply it down through both pieces. So x to the third times 10x is 10x to the fourth. And then x to the third times negative 6 is negative 6x to the third. I'm going to put this in parentheses now and subtract, just like we did with the other long division. Now by design, what you're going to notice is 10x to the fourth minus 10x to the fourth, that will disappear. And now we have 74x to the third minus negative 6x to the third. Minus a negative is actually addition. So 74x to the third plus 6x to the third is 80x to the third. And then I'm going to drop down my next term, negative 118x squared. That is the completion of one cycle. I can now repeat this cycle again. 10x divided out of 80x to the third. Now 10 out of 80 produces 8. X out of x to the third produces x squared. So 8x squared is the next term in our solution up top, but that has to get multiplied down through. 8x squared times 10x is 80x to the third. And then 8x squared times negative 6, I believe will give us negative 48x squared. This goes in parentheses and we subtract. Again, by design, 80x to the third minus 80x to the third goes away. And then we have negative 118x squared minus negative 48x squared. Again, minus a negative. That's why it's important to put it in parentheses, because minus a negative is addition. So negative 118 plus 48 gives us negative 70, and then x squared. Good. And then we drop down this other next piece, minus 48x. So that's our second cycle completed. Let's do it again. So the 10x again, divided out of negative 70x squared, produces what? 10 out of negative 70, that produces a negative 7. X out of x squared, you're just left with an x left. So negative 7x is the next term in our solution. Multiplying that down through, negative 7x times 10x is negative 70x squared. And then negative 7x times negative 6. Negative times a negative is a positive, so that's going to be a plus 42x. Put that in parentheses, and we do our subtraction. By design again, negative 70x squared minus negative, that's actually plus 70x squared. Negative 70x squared plus 70x squared goes away. I now have negative 48x minus 42x. That produces a negative 90x. And then I drop down my last term. I think we have one more cycle to go through to get our final solution. Yeah. So starting the cycle again, 10x here goes into or factors out of negative 90x, and what's left? 10 factored out of negative 90 produces negative 9. X factored out of x, that goes away. So negative 9 is the next term in our solution. Multiplying that down through, negative 9 times 10x is negative 90x. And negative 9 times negative 6 is positive 54. Put it in parentheses and subtract. So negative 90x minus negative 90x, it's actually plus by design, that goes away. And 54 minus 54, well, that just produces 0. We have 0 left at the end. So my 10x to the fourth plus 74x to the third minus 118x squared minus 48x plus 54 divided by 10x minus 6 produces the solution of x to the third plus 8x squared minus 7x minus 9. And there's no remainder. Our remainder is 0. There's nothing left over at the end. So there's our first example of doing long division of polynomials. We want to run through another example for two reasons. Number one, to solidify the concept we saw in this first example. But then second, there's something we have to be careful of in regards to how we do long division. There's kind of a wrench that gets thrown into this that the next problem that we're going to look at illustrates. So here is that next problem. Next problem is 6x to the fourth plus 7x to the third minus 12x minus 7 divided by 6x plus 7. And so again, we set this up. The first piece is our dividend. It goes underneath the division symbol. That's 6x to the fourth plus 7x to the third. And here's where our first intricacy comes into place. You'll notice that we're skipping over x squared. There's no x squared term in the dividend. When you do long division of polynomials, you have to have at least a placeholder for every term. You cannot skip terms. So what we're going to do is we're going to do plus 0x squared as a placeholder. And then we can continue on with negative 12x minus 7. Then our divisor that goes out front is 6x plus 7. So the first intricacy here is that you have to have a placeholder for that 0x squared because we skipped over an x squared term. Okay. So now that we have that taken care of, we can go ahead and start the division. So how do we start? We start with our 6x right here. 6x factored out of 6x to the fourth, 6 out of 6, that goes away. X out of x to the fourth produces x to the third. So there's the first term in our solution. Multiplying that down through, x to the third times 6x is 6x to the fourth. And x to the third times 7, that produces plus 7x to the third. This goes in parentheses, and we subtract. So 6x to the fourth minus 6x to the fourth, by design that goes away. But look what happens here. 7x to the third minus 7x to the third, that ends up giving me 0x to the third. It goes away. Okay. And then we drop our next term, which just so happens to also be a 0 term, 0x squared. So what I have to do in this situation is I have to keep dropping down until I have a term that's non-zero. So I'm going to drop down until I get my negative 12x. This is now the term that I'm going to use for my next cycle. So 6x factored out of negative 12x, 6 out of negative 12 produces negative 2. X out of x, that goes away. So my next term is just a negative 2. Multiplying that down through produces what? Negative 2 times 6x is negative 12x. I'll bring this 7 down right here. And negative 2 times 7 is negative 14. This goes in parentheses, and I subtract. Negative 12x minus negative, which is plus 12x, that goes away, again by design. And then negative 7 minus negative 14. So that's really negative 7 plus 14, which produces a positive 7. Produces a positive 7. This now is our remainder. Okay, so our solution that we have for this division is x to the third minus 2. But we also have a remainder there that is floating around. How do we deal with a remainder? How do we write it? Okay. Well, to do that, let's briefly go back up here to this first problem that we worked on that was similar to what you'd see in elementary school long division. We had 570 divided by 4, and that produced 142, but a remainder of 2. So how would we have taken care of that? The solution is 142 plus, we would always do our remainder divided by our divisor. So 2 over 4. So it's really 142 plus 1/2, because my remainder is half of my divisor. 142 plus 1/2. Well, this is the same exact way that we're going to approach it with polynomials. Once we get our solution, if we have a remainder, our solution is, well, in this case, x to the third minus 2 plus my remainder divided by my divisor, which is 6x plus 7. This is now my final solution. So we've seen two different examples of solving or performing division of long division of polynomials, and we've seen one situation in which there is no remainder, and we've seen another situation in which there is a remainder. Well, there is significance to that, okay? And it has to do with whether or not the divisor is a factor of the dividend. In other words, does the divisor go perfectly or evenly into the dividend? Yes, if there is no remainder. No, if there is a remainder. So if we go back up here to the two problems we did, in the first case, we had no remainder. That means that our divisor of 10x minus 6 is a factor of 10x to the fourth plus 74x to the third minus 118x squared minus 48x plus 54. It is a factor, meaning it goes into it evenly. Okay? Well, in this other case here, we've got a remainder in the end, which means that 6x plus 7 does not go evenly into our divisor. So in this case, since we do have a remainder, yes, we have a remainder, therefore 6x plus 7 is not a factor of 6x to the fourth plus 7x to the third minus 12x minus 7. So if there is a remainder, it's not a factor. If there is no remainder at all, then it is a factor. The divisor is a factor of the dividend.